two names are very big shoes to fill, and I'll try to do my best. It's not my paper, but yeah, we have some scheduling conflict, and unfortunately, Karin, who was going to present, is not going to be here. So I must apologize because standing in for Karin for a presentation is really, really not easy. So to those of you who came here expecting to see her, sincere apologies. All right, the name of the paper is actually not here, but it is the Smart Engineering Curriculum. And I think nowadays, the expression smart anything instantly elicits the concepts of Internet of Things and Industry 4.0 and all of those things. And notwithstanding what Prof. Jonathan Jansen said yesterday, we need to accept that Industry 4.0 and these type of problems are very, very real nowadays. And we know that because industry is complaining about them, and they're complaining about the graduates that we are putting out there and their abilities. They say that the graduates cannot operate at complex, at the level of complex systems that integrate hardware and software. And also at the same time, we know that companies in their effort to remain efficient and competitive are really starting to collect a lot of data and they're literally drowning in data, not knowing what to do. So the role of complex systems is to address that. And the idea of this paper was to, in Karin's work, to problematize the relationship between the different layers, the engineering layers in a multidisciplinary system. And we look at what that means in a second, but to do that, Karin and Martinez, they use the epistemic plane. I hope that everybody is familiar with the epistemic plane, but in effect, what it is, for those who might not know, is that it's this thing that is here, and there are two axes, and the vertical axis indicates the strength of a concept identity, and the horizontal one is how fixed or open-ended the approach is to the problem. And we end up with 4 quadrants, and those quadrants essentially give us the ability to categorize ways of thinking of knowledge practice. And so essentially it took Karin and Martinez because what Karin brings to the table is her expertise in knowledge structures and engineering problem solving, and Martinez is an expert in complex systems approach to complex system design. Let's see, yeah, they had 2 sections to the thing. The first one was essentially a study that they did, and they used these concepts to analyze a sample of engineering practitioners and how they navigate this thing here in approaching a problem, how they analyze it, identify the root cause of the problem, and eventually solving the problem. And the outcome of that study was that the successful problem solvers, the engineering problem solvers, was they could constantly shift and navigate across this entire plane. So they would, you can move from here to here, from there, constantly, and that's what the typical complex multidisciplinary system approach requires. All right, so what I mentioned at the beginning that we will come back to is this. This is the way that, after some analysis, that the typical curriculum looks like for a smart, what we call a smart engineering curriculum, right? So we'll see that if you pay attention here, it's very faint, but you can see that each layer here actually takes up a number of these things. So any one of these components here belongs to 2 or even 3 of these layers, and that's the nature of a complex system. So the problem here is that the solution doesn't work like that. This is how we present it, but the typical design of complex systems, the successful design requires you to look at it the other way around, from the top to the bottom. And the issue here is that the complexity of the thinking increases as you go that way. And that means, this is beautifully mapped here in color, that an engineer needs to work around here on the 5, needs to start the project from 5, but we actually teach it from 1 to 5. And so the outcome of this is that, or the result of what we can take away, is that we need to, as educators, we need to reconceptualize what it means to develop system thinking stability, because obviously we're doing it wrong and we're not succeeding. And secondly, the pedagogic approach needs to shift towards student-centered and self-regulated learning ethic, in the worst fashion. Okay, so that's it. I hope that you could follow my accent and everything.